Hello, everyone, and welcome to today's learning session with Cisco U. My name is Parmarat, and I'm the Vice President of Cisco's Learning and Certifications. It is great to have all of you here today, and I want to thank you for taking time from your busy schedules to be with us. In Learning and Certifications, we strive every day to provide the right training for you in the most efficient, effective, and easily digestible way. And we're focusing on doing this through Cisco U. I also want to take an opportunity to welcome new community members who may be joining us for the first time. Over the last 12 months, we have seen a significant increase in our community membership. So welcome. We're also fortunate to have a number of CCIEs with us today. And thank you in particular for being such a valuable and important part of the Cisco learning community. I also want to call out that everything we cover today will be made available in Cisco U. So make sure that you are registered. Through our accessible learning paths, tutorials, and podcasts on Cisco U, we are making it easier than ever for you to obtain the new skills to keep your certifications current, as well as earn new certifications. And again, thank you for being such a part of our vibrant community. So let's talk about what we're going to be covering today in today's webinar. We have some really exciting topics for you. We're going to be diving into the hot topic of infrastructure as code with CML, which is our acronym for Cisco Modeling Labs, as well as talking about cybersecurity. Session 1, we're going to outline how networks have always been defined by their code. There are going to be some demos on infrastructure as code, demo on automation tools, as well as we're going to cover domain-specific language. And I'm quite confident that you will find this useful and practical. The second session, we're going to be highlighting the latest cybersecurity threats and how you can build strategies to protect your networks. Security is such a hot topic, and it reminds me that with every new technology that hits the market, that's the good news. It's just another potential security risk for bad actors to target, which is why we need to keep our skills up to date and relevant. Every day there's news about cybersecurity, whether it's the latest breach or the new technologies promising to combat it. Look, human-driven responses to cybersecurity are just failing to keep up. There's no way to keep up with the automated attacks due to the rapid pace of cybersecurity threats. In fact, 77% of organizations are finding it difficult to get the skilled talent they need to fill the roles based on these threats. 64% of companies believe that training and certification programs are the key to enabling the talent to fight these threats. And that's where all of you come in. And that's where our training comes in. So what are we doing to help with cybersecurity? In addition to everything that we've done with Cybersecurity Month, I want to also make sure that everyone is aware of our new multi-cloud certifications. These new certifications are critical to any cybersecurity planning, and all of you play a critical role in ensuring we are living in a secure world. Why? Because the network is still the primary system for record of attacks. And no one knows the network better than all of you. So I encourage you to take a look at our Designing and Implementing Cloud Connectivity Certification Blueprint, as well as the Designing and Implementing Secure Cloud Access for Users and Endpoint Certifications Blueprint. These are very practical in their training and in their application. You'll be able to design, configure, and establish secure connections within the cloud network architectures and implement Connect Cloud technologies while continuing to adhere to best practices in cloud security. These are critical skills, both high in demand from a career standpoint, but I would also suggest from a societal standpoint. And that's because all of us are customers of our customers. We all have health records, we all have mortgages, we all have financial data, and we need to keep these safe for your customers, but more importantly, for your family, for your friends, and for ourselves. So I hope everyone has a wonderful session today and comes away inspired to learn and take advantage of the training that is available. Again, we're committed to providing the right training, the right learning to help all of you be successful in your careers and in your organizations. Keep the feedback coming. We appreciate your input, and we're making sure we are meeting the needs of what all of you need in the community and what you need for your organizations. I'm now going to hand it over to Matt Sanders, who's going to guide you through today's exciting webinar. Thank you.
Thank you so much, Par, and hello, everyone, and welcome to today's event. Let's see, I would like to first just reiterate the appreciation Par expressed for you joining us today. We know how busy everyone's schedule can be, so we're very grateful that you can make the time to be with us live today. And we hope you're as excited as we are for today's sessions. My name is Matt Saunders. I'm a community manager for the Learning and Certifications group here at Cisco, and I'll be your host today. As we get started, we would also like to invite you to participate in our Q&A for each session by logging into the Slido event we have set up, and you should see exactly how to do so right here on the event page itself. We'll do our best to answer as many questions as possible during the live event. However, we also have a post-event discussion created for you over on the Cisco Learning Network, where we can work on answering further questions once the event wraps up. And let's see, just two more housekeeping items. First, yes, the recording will be made available shortly after the live stream ends, and you can access the recording right here on the very same page of the live event itself. And last, I would like to call your attention to the resources section of the event page, where we have curated a few recommendations for you, including some fantastic tutorials related to today's sessions. You'll find these free resources available to you as a part of your free subscription to the Cisco U. Let's see, and with that, let's go ahead and get you right over to Quinn for our first presentation on infrastructure as code. Quinn, please take it away.
Hey, Matt. Thanks for that great introduction. For those of you who don't know me, my name is Quinn Snyder. I'm a technical advocate with Cisco Learning Certifications. And today I want to talk about coding the future, talk a little bit about kind of the history and past of why we have gone down the path that we have with automation and tooling, some of the common tools that we're dealing with, and then unlocking some of the magic and power that can really come, not only from using automation tools, but when we start building things with abstractions and abstracting away a lot of the complexity, some of the really cool stuff that we can do behind the scenes with our infrastructure. So like I said, this is Coding the Future, Unraveling the Magic of Infrastructure as Code and Universal Automation Tools. As I kind of said in the introduction, we'll talk a little bit about a brief history of network device configuration. So we'll dive into how we started and really kind of the myth and the legend and why a lot of us really got into networking in general. And then we'll talk about why we have had to evolve between hyperscalers and cloud automation, web-driven UIs, all of the things that have required us to not only shift away from our magical blue cables, but forcing us to adopt new ways and integrating and connecting all of these disparate pieces. And then we'll get into a little bit of a demo of all the power that you can use when you actually codify your infrastructure using an abstraction like an infrastructure as code tool. So with apologies to Stephen Hawking, let's get into a brief history of network device configuration. Now, I found this picture and it really spoke to me because this was the kind of thing that I saw in all of my Cisco Networking Academy classes and all the Cisco textbooks. It was really indicative of why I want to get into network configuration, network engineering, network architecture, because this looked really cool to me. And I'm not going to guess too much on the age. I see a lot of like X2 type pluggables, so I'm guessing this was really in the heyday era of network engineering. We have a gentleman who's sitting there. He's cabled in to some network devices, and he's probably performing a lot of manual configuration based on the CLI. That's the tool that we've always known. That's the tool we've always loved. Can't guess on which terminal emulator he's using, but I'm willing to bet that he's talking to something in Cisco iOS just based on that stack of switches that's there. And that was our norm. We consoled into something. We had this special language that we all learned. It was Cisco iOS. And with that, we could do magical things. We could build enterprise architectures. We could build data centers. We could build service provider networks. And we had this one unified operating system and language that was Cisco iOS. And we were tapping on our keys, sometimes angrily if things weren't working at 2 in the morning. But again, that was the allure. It was we were building the internet. And you started off as a CCNA, you progressed to a CCNP, and we wanted to be like those CCIEs, those mythical legends that were there who could solve any problem with a packet trace, some kind of sniffer, and being able to understand the protocols. And that was it. That was the pinnacle. And I would venture that a lot of us got into network engineering because we didn't necessarily want to learn coding languages. This was language enough for us. And we created some really cool things. So, we had some configurations that we built, whether it was through routing protocols or VRFs. And the biggest changes that we had to endure were really around the language changes. So we had NXOS, or we had iOS XR that was actually introduced before NXOS. So we were a little bit grumpy that we had to learn something new, but that was most on the service provider side. A lot of our core enterprise architectures were still built using iOS. And then along comes NXOS, and we were grumpy about that because it was just close enough that we would fat finger some things, or we would assume that it was one syntax when it was actually the other. But again, things were good. We had this thing, we had these languages, they were our code. We didn't need to learn anything different beyond that because there was only a few languages we needed to speak, and it was code in and of itself. When we wrote configuration that defined our network state, it defined our intent. But if you take a step back and look at some of these configurations, there's a lot of repetitiveness. And we started to see early on as we scaled these networks that maybe there was a slightly better way. Maybe we used Excel templates. Maybe we had some kind of expect or things that we used to build repetitive configurations, find and replace, Word documents. But again, minimal automation was needed because things were pretty templated, and we could build our networks as we saw fit using the few languages that we needed to have at our disposal. And at the end of the day, our ClickOps weren't necessarily that complex. I say that, of course, being in tongue-in-cheek, because anybody who's used Visio or some kind of network diagramming tool for any length of time was, getting your diagrams correct was really intense. You had to click and drag and make sure the points were intact, and they conveyed your intent at layer 1, at layer 2, at layer 3. So these diagrams become very complex, but that was the extent of our ClickOps. And as having supported networks as a post-sales deployment engineer, having supported customer networks, having had to go in as a pre-sales engineer, documentation was kind of, it could be sparse at times. So I could tell that a lot of network engineers weren't really into the whole ClickOps thing to begin with when it came to documentation. But again, our lives were focused on the CLI. We tried to do a little bit of automation where we saw fit, and documentation was some of the things that we did when we had the time, which quite honestly was never. Now, that's not to say that there weren't things that challenged us a little bit. We, as our networks grew in complexity and we needed to worry about bandwidth considerations, we may have used something like Cacti or SolarWinds to graph some network throughput at our edge to make sure that we were staying within our constraints or bandwidth that we needed to know if we needed to upgrade. There were things that we had to do, and in the top right is actually a snippet of having to upgrade some ASR 9000 chassis. They actually shipped with an expect script to do that updating because manual hands couldn't do that fast enough. So there was some basic automation. We may have also done some TCL or tickle automation using our routers to do ping tests and things like that. And then finally at the bottom, if we had a tool like ICE or something that was providing some visibility or .1x or user-based RBAC or things like that, we may have needed to use a GUI, and we could, we had some methods and procedures that allowed us to go in and document where things needed to be and how we needed to add users or change permissions or things like that. But that wasn't very often because We would snap it into something like Active Directory if we wanted to have user authentication. We may have had a separate database for network device authentication, and those users didn't change very often. The permissions were fairly static. And yes, we may needed to change policy, but quite honestly, we kind of may have pushed ICE over to another team, whether it was our security teams or something like that, to make sure that those policies were intact. Again, this really reinforces that whole, we didn't do ClickOps, we didn't do GUIs, we had our own code, and life was good. Life was really good. And like I said, I imagine that that's why a lot of us got into these things, because we weren't programmers. We didn't want to be developers. We liked making the internet. And we were really good at building those network architectures and infrastructures that allowed everybody to communicate back and forth. And you got that sense of accomplishment, when you clicked in a network cable and the light went green and you were suddenly passing traffic. And that was really, from the time that I got started in the early 2000s. From then on, it was, and even before that was kind of the same way. It was just updates and speeds and feeds and devices that allowed us to really do the things that we were doing faster, but not a whole lot changed from the outside looking in. Unfortunately, there were a couple of big changes that were really developing on the back end, and we started seeing them at the end of the 2000s. The end of 2000s, beginning of 2010s, and we started hearing a couple of different terms that were becoming into our vocabulary. And this picture kind of shoehorned it in there, but it fits the picture of, we had these clouds, we had these things that were being developed. People were saying, how can we offload the compute from our local on-premises data centers that we house within our buildings? We didn't want to be in the electrical and cooling and power business. We wanted to offload those things. And so we had colos, but then we also had these things where people were renting spare capacity that we could use anytime. We just had to build a tunnel and use their capacity. And when we were done, we could destroy it and just pay for what we used. We also had the concept of these hyperscalers, and when we look at the popular web-based applications that we use today, they got their inkling started as just building distributed architectures across the globe. We may have had a small presence in different parts of the US. We may have had a couple of points of presence in Europe and across Asia, and we just interconnected those. So we had a better response time for our applications, whether that be global banking, whether that be social media, whatever the case may be. We wanted to have that better response time for our users. Well, eventually those needs became so large and so vast that we had these massive data centers that were wholly owned by these hyperscalers, that we had racks and racks of compute that all had to be networked, and that configuration needed to be similar across these disparate racks, whether they be sitting in the Bay Area in California, or whether they were in some remote data center across the Pacific in Japan or Singapore or in Australia. And the way that had to happen was through a consistency of templating and configuration. And so we started to see the inklings of these things trickle down at the end of the 2000s, beginning of the 2010s, where we could see things were changing a little bit. But we didn't know that as network engineers, we had to change our thought process, because at the end of the day, if we weren't working for a hyperscaler, if we weren't working for a cloud operator, we could still use our normal process and try to configure our devices the way that we needed to, and the way that we were used to, more likely. And then we had the API revolution. Now, early days of APIs, I won't comment on how good or bad they were, but they existed. And what we started seeing was that as we were consuming resources from our clouds, from places like AWS and Azure and GCP, we were starting to move into differentiated architectures within our data centers with ACI and things like DCNM controlling our VXLAN fabrics. Whether we had an off-premises data center that was through a third-party co-location facility, but we could use to spin up different pieces of our architecture through their APIs, or we had a bare metal hosting provider that would do that for us. We had to manage that, and then we started seeing the trickle-down effect of those APIs fall into our standard on-prem routers and switches. It started off in the probably early 2010s. We had things like 1PK, and then we started seeing some SSH automation with Ansible, and then we started seeing a larger uptake of things like NetConf and RESTconf. And then we had these abstraction tools that were built on top of those things, where we could start ingesting all these different methods of configurations. and then trying to normalize them across all of our different locations. And again, we saw the value in these things. We wanted to work with APIs, we wanted to use them, but we still had this disparate set of teams. We had our network operations team, our network engineering and architecture teams that were more concerned about how do we use our on-prem resources. We may have had a cloud team that was building these cloud native applications, building their Kubernetes clusters or moving things to containers, or even serverless functions out into the respective clouds. They were doing all of that application level engineering and development. They may not have had the strongest network background, but eventually those two things would have to interconnect, and they would get in a room and you'd whiteboard it out, and the configurations that needed to happen to bridge our on-prem resources to the cloud were fairly simple, and we didn't have to do that very often. We would build a few tunnels up to these cloud providers. And sometimes it was just one cloud provider that we had to build a few tunnels based on our zones or regions that we wanted to operate in. And they were pretty static, because once we were connected to those cloud providers, it was like any other external connectivity, whether that was through some kind of IPVPN link, or it was through some kind of direct connection with our providers. Same kind of principle. We would connect once, we'd build some configuration. Maybe we had to tweak a few access lists back and forth to allow the proper subnets, or maybe we need to add a new subnet or revoke a subnet, or maybe there's some security incidences where we needed to block or outline a few things. But again, those configurations were pretty static, and we didn't necessarily need to use those APIs. And it was still kind of a foreign thing to us. We had to write in Python. We had to build code. We were doing all the things that we didn't want to do when we started to down that network engineering path. We had invested our time in becoming certified. Maybe we were CCIEs, and we were comfortable with what we were doing because we were still experts, and we were still needed to accomplish that complex engineering. And we didn't necessarily need to learn those languages. So on top of that, there's a large fragmentation in the way that these languages were developed. From a cloud perspective, we may have had things like CloudFormation or Amazon CDK, which was recently released. Azure has Bicep language up there at the top. Google has a cloud development kit that supports multi-cloud native. We have things like Pulumi, which was released a few years ago, which kind of does a lot of abstraction across all the different clouds, but we need some kind of interpreter to work between them. And then we have our trusty Python and Go. All of these things required us to use the native APIs that were provided to us from our clouds in order to interconnect these things. And we had to not only understand those APIs, but if we wanted to even integrate those at some level with our on-prem infrastructure, to do that automation that we heard was coming, we would have to do a lot of data normalization. So depending on how we receive data from one API, we may have had to strip and transmutate and make sure it was formatted correctly to be able to use that against another device's API. And again, to be honest, a lot of us didn't want to go down that computer science engineering path. We were very comfortable with our network engineering, our few languages. We knew how to parse that unstructured data. We knew what was important. We knew what wasn't. We could strip out the fluff and move those things back and forth. And we had our templates. We had our rudimentary automation systems that we may have built with something like PHP or Perl, or even just an Excel spreadsheet with some variabilization. We were comfortable with these things, and we didn't want to get into a lot of that data normalization. And then there was, I would say, kind of a revolution. I've lived in the space for a little bit, but the two tools that really came out that accelerated a lot of these adoptional changes were a couple of infrastructure as code tools, namely Ansible and Terraform. What Ansible had done way back when, I would say 2015-ish, 2014 even, was it allowed us to natively take SSH connections to our network devices, and through the miracles of regular expressions and data parsing and formatting, would strip out the important pieces that would turn into variables that we could then use to feed other automation pieces. Not only was it Cisco-centric, but it also had support for clouds. It had support for our UI-based controllers, and it was multi-vendor. We could work across different vendors if we needed to, whether they be cloud or on-prem network equipment, servers, infrastructure management tools. It was supported. The same with Terraform, but done in a slightly different way using REST APIs rather than native SSH connections. Both of those things allowed us to remove some of the complexity of the programming and development that we avoided as network engineers early on, and allowed us to focus on our intent. It gave us that same ability that we used as network engineering professionals. We knew what data was important, what wasn't. Ansible would allow us to focus on extracting that data that we knew was important, and allow us to modularize that data, those data pieces, those data sets, and put them into a configuration somewhere else where we needed to, seamlessly, just by building a playbook. Now, that's not to say that these things were completely plug and play. We do need to learn we needed to learn those domain specific languages, whether that be YAML or HCL. There was a bit of a learning curve, and there is some adoption pieces there, but that abstraction, that removal of the complexity of all of that programming underneath, allowed us to say, we're going to focus on our intent, get us back to our roots, so to speak, of being able to figure out what's important in our network in the state, and allow us to focus on creating those configurations, and again, apply them seamlessly, whether that be in the cloud or on-prem. And getting back to those domain-specific languages, we have Terraform's HCL on the left and Ansible's YAML on the right. These are a couple of different things. One is just to set up some configuration in AWS. I could have done this elsewhere. I could have been using ACI, I could have been using NDFC. We could have used any of our native tooling, say something like ICE or something like that on-prem. But again, we're focusing on something that's while it may look intimidating with all the curly braces and equal signs and things that we wanted to get away from when we were coding, it's still human readable. We know what these actions are doing. We know we're creating, in this case, a VPC, some security groups. We're building an instance of an EC2. We have some pieces behind that in terms of disk sizes and how we can set up some SSH, maybe some post-installation scripts. We can read that and we can understand the intent behind that, because we've abstracted the complexity that comes with those programming languages and say, now we're focusing on our intent. And the same thing over on the right-hand side. Some may say this is a little bit easier. It's YAML. We've been more familiar with YAML because of Ansible's kind of prevalence early on and that first mover advantage in the network automation and configuration space. Something very simple, we're creating some NTP servers across iOS XE and NXOS devices. Yes, there is some things that we need to learn, like what exactly are we doing with the double curly braces when it says item? How are we looping through there? Where are those variables stored? What does that state mean? Again, these are things that we need to learn, but it's very human readable. We know what we're doing, and so we don't need to necessarily focus on becoming programmers. All of that complexity has been abstracted away for us, and really, like I said before, get us back to that state, that what we wanted to be when we were network engineers. We didn't want to be developers. We didn't want to be coders. We didn't want to be programmers. That's why we're probably network engineers. This allowed us to focus on that intent and not about the complexities of the language itself. And this is what we've called infrastructure as code, kind of as a standard. Now, you may say, dude, where's my code? And I like this because it really challenges kind of the thinking of what we mean when we say infrastructure as code. And it goes back to my original point. When we had device configurations in iOS and NXOS and XR, that was our code. It may not have been executable. We may have had to copy and paste it in through a terminal window or some kind of SSH session, but that was our code. That was the thing that we learned, and it was declarative. We said we are going to put this. Declarative in as much as we were declaring this. It's still imperative in the native language, but that was our intent. What we desired that configuration to be. We just had to put it in that specific language. In this sense, declarative configuration with Ansible or Terraform is declarative in as much as we don't necessarily need to worry about the syntactical differences, whether I'm writing against a cloud provider or whether I'm writing against an on-prem resource using Ansible or Terraform, that will look the same. So we've abstracted away the nuts and bolts behind that. But just because it's not written in Python as you see it doesn't mean it's not code. Each of those DSLs has an interpreter that funnels it down through some other code, and natively will do that interpolation for you. But the best thing about that is that unified domains specific language, whether we're writing in HCL or YAML, allows us to create portability. I don't necessarily need to worry about all the dependencies that go into building a Python application, like all the different modules and which Python version, which do I have it installed in system or some kind of virtual environment. I've written that configuration. That's what I intend it to be. I can hand it to someone else and say, here's what you need to run it. And they can run and build it themselves. And it allows us to create that modularity between different instances. And I'll show her the power of that in a little bit of a demo. The other nice thing about it is those domain-specific languages create a config intent. By writing something in HCL, by writing something in YAML, I've defined what I want that configuration to be. And by archiving that, we can track the changes over time. We can track the state of our network. And because if we snap it into some kind of version control system like GitHub or Bitbucket or GitLab, we can build some kind of pipeline for some kind of automation routine. So we're not even having to apply that configuration locally on our laptops. We can do so by just using the tooling that we build into our VCS and create that pipeline. Now, I say all of this and kind of, I don't want to get into the hand wavy sense of we have this very easy path to get to automation. If you look at a lot of slide decks, we kind of have this easy progression of we start with APIs, we learn languages, we snap that into a VCS, then we learn our IAC tools. And once we have that IAC abstraction, we can build our own pipelines. And while that may be true, that may be a progression for some, that kind of doesn't capture some of the actual complexity that goes in behind building these pipelines. A lot of us have started with learning those APIs, like I said, way back when those cloud providers came out, or we were dealing with hyperscalers or even our co-location facilities. We may have started exploring those APIs. And then we may have moved to Ansible. Ansible is kind of what I call the gateway for automation, just because YAML is very human readable. From there, it gets a little fuzzy. Maybe we said, well, okay, we're going to learn some Terraform and HCL. Some may have said, well, there's not a whole lot of power in Ansible. I don't have those programmatic loops that I'm used to when building an actual program. You know, we may have gotten excited by going back to our university course and say, oh yeah, I actually did learn and enjoyed programming, so I want some more power behind that and build my own apps. And maybe you move to Python, or maybe you jump to Go. And then you say, okay, now we're going to snap these things into a version control system because we want to be developers. We're going to put all of our code in some kind of VCS and archive it. And then we build a pipeline behind that. And once we go through that whole exercise, maybe we go, that pipeline, it's fairly fragile. It's really tough to build. And I've got to worry about all these different complex inputs and sanitizing things and making sure that things are in the right format. And I've got to do all that data normalization, all those things that come with that. And then maybe I might jump back to infrastructure as code, because I say, yes, I lose some flexibility in terms of what I can actually do with the language. I can make it do things that, if I'm writing in Python, I can make it do things that I can't natively do in Ansible without a lot of trickery. But we say I can accept that. I can accept that lack of control and flexibility for something that does all that data normalization, all that boilerplate work for me. And so what I have seen, especially over the past year, 18 months, is a lot of professionals who said, I'm abandoning IAC, I'm writing everything in Python or Go, say, okay, yes, I still need to do that. There are times and use cases where that becomes important, but I'm also supporting things with Ansible. And as those languages and as those tools have improved, we have things like event-driven automation. We have things that allow us to be proactive in our automations rather than reactive through manual config pushes or pipeline pushes. So we can see that by leveraging things like infrastructure as code and infrastructure as code tooling in our pipelines, we can gain a lot more time to delivery and some much cooler tricks than having to write that ourselves using a native programming language. And I will say this is abstractions remove obstacles, mostly. I mean, there's a little bit of hand waving there. And I say that because not only can we deal with abstractions in our domain-specific languages using things like Ansible, using things like Terraform, we also can provide some abstractions when we're building our CI/CD pipelines. And this is just one example of something that exists. It's called Atlantis. but we can use it by running a simple build server command. We can write things in our domain-specific language, in this case, Terraform HCL. We can push that to our VCS, and by having that VCS configuration at the ready, snapped into our build server, anytime that we do a push, we can have Atlantis do all of the heavy lifting for us. In this case, it will automatically perform those Terraform actions that we're used to when writing in Terraform, but do that as part of a GitHub PR. So I've abstracted not only the programming language that I'm used to writing in, so I've abandoned things like Python and Go, and I'm focusing on Terraform. But then I've abstracted the CI/CD pipeline portion using a very simple web application and some webhooks between GitHub and my build server, which allows me to build a very quick pipeline that allows me to do some network automation. And my demo for this is going to be using Cisco Modeling Labs for a target. And then I'm going to be building some basic topologies using Cisco Modeling Labs and this abstracted CI/CD pipeline. Now, the reason that I'm using Cisco Modeling Labs, it's a great thing to get started with. Whether we're doing our CCNA studies or whether we're doing some complex CCIE studies, CML is out there in the wild and we're all using it. It's available through a variety of different channels. Some of them are free and reservable through other parts of Cisco. Some of you can purchase a license for personal use. We have large enterprise versions, which allows us to do some multi-tenancy. But the best thing about that is not only do we have this very powerful modeling software, but it's also all API enabled, which allows us to use tools like Ansible, use things like Terraform to interrogate those APIs and make them do things. So not only are we learning, we're kind of killing two birds with one stone, if you'll excuse the analogy there, but we have an ability to say, not only are we building these topologies that we need in order to further our studies or further our exploration or whatever the case may be, solve a difficult problem within our network, but we can also use that to play with our API knowledge and how we can query APIs and get data back, or use APIs to instantiate or remove or change things. And that's really the important piece of it, because when we've all started out, the reason that folks become certified and they're very good at things is we were able to take the things that we were learning initially when our CCNA and CCNP and CCIE studies and be able to put them in practice during our day jobs. We were studying to be network engineers while we were working in the network operations center, or as a junior admin or some kind of junior professional services engineer. We were able to put those things into practice and keep learning and growing. And by using the same software to not only model our networks, but be able to use them for API exploration, kind of allows us to do both of those things. It allows us to learn those APIs and further our knowledge and change the way that we're adapting these things. Because at the end of the day, the CCIE, it's a very valuable certification, and I will never say it's not worth it. But the demands of those really skilled network engineering professionals are being scattered. We're not still in the days where we only have a few languages we need to learn. We're worried about GUI-driven controllers. We're worried about clouds. We're worried about co-location facilities. We have a variety of different tools. Maybe we've got to integrate some collaboration or security, or bridge our data center and our enterprise campuses. Those different technologies and blending, it becomes very disparate and dispersed. And we need to make sure that we're able to orchestrate all these things collectively. So while we need the knowledge and the skills and the backing behind those different technologies, we also need a quick way to automate and to build those things quickly and ensure configuration consistency across all those pieces. So without further ado, I will jump into the demo here, and we'll get to see kind of the setup and what's being done behind the scenes and how quickly we can actually build the configuration that allows us to run this abstracted CI/CD pipeline. So behind the scenes here, nothing too fancy. I have a Cisco Modeling Labs instance. Right now, it's not running any simulations. We can see that the one network that we have defined is there, but it's not on, and we have a very low CPU utilization. So what I'm going to do now is start by just showing you that there's kind of the old Rocky and Bullwinkle trick, nothing really up my sleeve here. I'm going to start by building a very simple network using Terraform, and we have this Terraform network that's already been CML network, which has been defined with YAML. And all I'm using is this CML lifecycle piece here. And we have the configuration that's applied here. For those who are familiar with the CML YAML files, we'll be able to look at this. All of the code that I'm using as part of this lab will be available in the link that's at the bottom of the screen here, so you can play with it yourself as well. But just to show you that there's nothing crazy going on here, I'm going to plan my Terraform, and I'm going to apply, let's see your Terraform, apply, and we can see that we're going to be building this topology. And we can see it's instantiated using that YAML. All these routers are slowly spinning up. They have a configuration here. And let's see here, if I click on a node, should be able to see its configuration, maybe not until it's booted fully, but we have all this lab that's being spun up for us. Great. So we know that our Terraform is working. And this is how quickly we can build our networks using APIs and infrastructure as code. We have the output of that YAML file, that's portable. We have this main.tf file, which is also portable to build that lifecycle. But that's not really the whole point of what we wanted to do here. I want to show something a little bit more complex. So I'm going to go into my folder here, and I'm going to, so I have a Git repository that's set up. Right now I'm in my main branch, and I'm going to check out, git checkout, a demo branch, and I'm going to copy the main.tf file for a slightly different configuration and move it into this branch. Now this main.tf file will look something like this, where we have not only defined our lab, but we're building everything in a Terraform-centric way. So I'm defining my nodes, I'm defining all of my links. Everything is just as you would expect if you were doing this by hand. Now what I'm going to do is do a git add and add that file, and I'm going to commit it to my directory. I'm going to do a git push to the appropriate branch on my remote system. So I've pushed this out to GitHub, and we can now see that I have had this branch that has had a recent push. I've created the scaffolding inside of that, but I'm going to create, so we have the second branch, so we have all the configurations that we needed, but I'm going to create a pull request that's going to move that main.tf into the main branch. And I will create this pull request. And you can see that I have this tool called Atlantis that is running in the back end. And what that has done is created a pipeline for me that says, I see that you have this main.tf file. Here's the output that will be applied if we were to run that main.tf against your endpoint. In this case, that CML server. We can see we're building each of the nodes, the links, and everything as we would expect if we were running this file using standard Terraform. Now, when I do an Atlantis apply and comment this as part of my GitHub PR, I'll comment that, we'll see that it's now going to run a separate apply in progress. So we can see we did the plan, and now we're doing the apply stage. And within inside of our CML server, we now have this second demo that was built automatically using our CI/CD pipeline. And using Atlantis, we can manage that full life cycle. We can remove this if we need to. We don't have a whole lot of time because it takes 3 to 4 minutes to build, but we can do a delete. We can manage that complete life cycle of the infrastructure all by using our GitHub PRs, and everything has been automated because we have used abstractions in our languages with the portability, so we know what's being defined where and how it's being defined, and then abstractions in our CI/CD pipelines to be able to say, we're only going to accept Terraform HCL files, we're only going to push them a certain way. So we've created those baselines and standards that allow us to use those abstractions, sacrificing some flexibility for the ease and portability, And now we've been able to build our infrastructure completely using abstractions and CI/CD pipelines with infrastructure as code. So with that, I'll conclude. Like I said, all the code will be available and we'll have the links to that posted. I'll be around for additional questions after the fact here. And I appreciate you joining for this event. The one thing, if there's one takeaway from all of this, and let it be this, it's that the knowledge that we need to acquire as network engineers hasn't necessarily changed at its fundamentals. I use a lot of analogies, especially around ducks. Networks are still ducks. They're just slightly different breeds of them, so to speak. They still walk the same. They still talk the same. They pass packets. They connect users. They bring data from one place to another. The only thing that has necessarily changed is how we approach them and how we approach our configurations. We're now doing a lot more GUI-driven automations. We're doing things via APIs. We're doing things in clouds and with co-location facilities and remote firewalls and things like that. But at the end of the day, we still need that subject matter expertise in order to be able to configure all those things successfully. We just need to change some of the ways in which we adopt and implement those things to ensure consistency and portability. And this is one way of doing that. Thank you.
Okay, thank you so much, Quinn. And just a quick reminder for folks, this event is brought to you by the Cisco U team, which is a part of the Cisco Learning and Certifications organization. And I want to be sure to draw your attention once again to the great resources we have curated on the event page for today's sessions. And definitely, we recommend exploring the free tutorials we have curated for today's topics. And be sure to stay connected with the team via the community space we have for you and others pursuing Cisco certifications over on the Cisco Learning Network, as well as our YouTube channel where we publish regular updates and bite-sized technical learning content. And so with that, as you're surely aware, October is Cybersecurity Awareness Month. And as we wrap that up, we felt like it's really important to give a readout of some of the top attack types so far in the year 2023, as well as recommendations on how you can protect your networks and all network environments. And so it's my pleasure to introduce our next speaker, Yuri Kramars from the Cisco Talos Group. Talos is our cybersecurity threat defense team at Cisco, and Yuri is a senior incident responder with the team. And in his presentation, he's going to overview some of the top cybersecurity attack types in 2023 and the team's mitigation recommendations they have for all your network environments. And so Yuri, with that, thank you so much for joining us today, and please go ahead and take it away.
Hi, everyone. Good morning, good afternoon, good evening, wherever you are in the world. Today's session, we'll be talking about cybersecurity threats and effective network protection. I will do an overview of H1 2023 trends, as well as the defense strategies. My name is Yuri Kramars. I'm principal engineer working for Cisco Talos Incident Response. Now, today on the agenda, we've got 3 major points. So we're going to talk about the top infection vectors. So what we see out there in terms of infections, how they actually happen in organizations, what are some of the interesting aspects that organizations get exposed to when it comes to compromises. We're going to talk about targeted verticals. So what are the verticals that we see our customers impacted by? And then we will talk about, of course, our defense strategies. Now, just for a very quick background, my name is Yuri Kramars, principal engineer working for Cisco Talos Incident Response, based in Qatar. I'm a seasoned DFIR engineer. Effectively, my day-to-day job is to handle emergency response and incident response. I spent the last decade working in direct offensive or defensive cybersecurity practices. So I used to break into environments, now I'm defending them, and I'm located in Qatar. So this much about myself. I'll now talk a little bit about Talos and what we do. So Talos is effectively a threat intelligence organization based in Cisco, right? The job of Talos is to protect our customers, and we do this through multiple different approaches to our environment and our partnerships, as well as our engineering teams. Now, we do, of course, provide threat intelligence introduction that goes directly to our Cisco product. So every time you hear about Cisco security, most likely the product that you're talking about and the product that you're experiencing, like say Cisco Secure Endpoint, is powered by the threat intelligence supplied by Talos. Talos also has an incident response service. That is this is the team that I'm part of. And this team is that effectively responds to cybersecurity incidents which are happening out there in the world. We perform detection research. So the job of detection researchers is to identify an interesting and novel techniques that adversaries might use to compromise different systems, and then create signatures for those. Likewise, we have vulnerability research and discovery teams who are effectively looking for vulnerabilities. So they're looking to identify systems and vulnerabilities that might be exploited by adversaries, write signatures before they become a real problem. And of course, we also have strategic planning, communication, and engineering and development teams, both of which work in tandem to make sure that whenever something happens out there in the world, we have signatures, we have discover vulnerabilities or discover right connections for us to create the signatures into different systems that we operate. Now, we are also partnering with different organizations. So every time we think about Talos, think about partnerships we do. It's very difficult to do this kind of work just by one organization itself. We do partnership with Interpol, NATO, and a number of other agencies out there to share and exchange threat intelligence. This threat intelligence is vital for some of our customers to find their protection and understand what are the adversaries out there doing. And what we also do is we use those partnerships to see some of the threats and see some of the vulnerabilities coming in as a kind of 0 days across different environments. Now, our job effectively is your defense. Now, everybody in Cisco, you will see this, that effectively we're a security company, right? And so we are defending Cisco customers. Everybody out there is doing their best to defend our customers. We do this through different products and services that we offer. And we also do this through different threat intelligence aspects that we as Talos offer as well. And of course, if you like to read about some of those stories and see some of the things that we do, I'd like to invite you to visit talosintelligence.com. This is our main page where you will see all the different information and threat intelligence that we're able to share. Now, with that in mind, let's jump into our top infection vectors. So let's talk about what we've seen out there in terms of vulnerabilities and in terms of the ways that the adversaries are getting into the environments. For example, in Q1 of 2023, the most popular method of breaking into various organizations was through exploitation of publicly facing applications. So those applications could be things like, for example, WordPress, they could be Magneto, they could be anything that organizations are using and exposing to the internet in order to facilitate some of their business transactions. Adversaries out there, what they do is they tend to scan the internet every day. They're looking to identify vulnerabilities. They're looking to find exploitation patterns that they can use to break into the organization and then progress naturally through the environment to try to achieve their objectives. Now, interestingly, in Q2 of the same year, so 2023, our most popular method of getting into the environment was through valid accounts. What does that mean? It means that adversaries somehow get a handle on the actual credentials that they can use to log in through, say, a VPN or remote access portal, and then use that to enter the environment. So most likely they'll be looking to try to identify how to exploit the internal environment by using valid credentials. So they might, for example, get credentials, enter through a VPN, and then try to progress naturally and move into different environments by exploiting different systems. One of the interesting things you'll see here as well is that we do have a number of unknowns. So somehow the adversary appeared in the environment despite the fact that there were no observed alerts or anything else like that that would indicate that there's actual active exploitation going on. Now that is possible because, of course, organizations are targeted to different adversaries pretty much every day. Their credentials might be shared through database leaks, for example. There might be third parties who are in charge of simply enabling access to organizations. So instead of trying to break into the organization, somebody goes out there and pays a little bit to try to get access to it. There are also applications called info stealers. And those applications, what they aim to do is they aim to steal credentials which are saved in the browsers or other parts of the operating system, and then use them or effectively share them with the adversary and then use them to access within the environment. So there might not be a clear answer to how some of those credentials or how some of the access actually was achieved by the adversary, but the impact is still the same. They were able to access the environment and then perform all kinds of interesting activities within that indicated they're successfully getting some sort of credentials. Now, if you look at the targeted verticals, so one of the interesting things that we like to do is we like to look into the organizations and we look into what are some of the verticals that are impacted by some of the hacking activity out there. Now, verticals are important because effectively, if we look at the different sectors and different operating places or different operating businesses, we can identify that there are some commonalities between a target by a particular vertical. So for example, let's say there's an adversary that might be based in somewhere in the world, like say, I don't know, UK, and they might be specifically targeting education sector. What we can notice quite a lot of time is that those adversaries will be honing their skills to do particular things. So if we're targeting, let's say, financial services, and we are targeting, let's say, holding companies, typically those organizations will have quite a lot of money. And because they have money, they'll be investing very heavily into cybersecurity. They might have the latest and greatest antiviruses, EDR products, proxies and DNS protection solutions and things like that. So then if the adversary is targeting the vertical, they are looking for different skills. They're looking to identify, for example, holes in EDR solutions to try to bypass them in order to execute some of their malicious activity. However, for example, let's say organizations in the education sector, they might not have as much money to develop and protect themselves. They might not have enough money to hire a number of cybersecurity professionals that can help them to defend their networks. And so they will be relying on some of the building protection within, let's say, Windows operating system or Linux operating systems when they run some of those environments. Now, if the organization like that is targeted by adversaries, most likely these adversaries will spend a lot of their time honing skills around, let's say, lateral movement and exploitation of vulnerable applications. And they won't need as much time to, for example, look for bypasses for security products such as EDRs. So looking at the first 3 quarters of 2022, what we found is that the education sector was targeted the most heavily across a number, effectively across the entire year, followed by local governments, and then finally financial services and energy sectors. Now, a lot of the other verticals that we see here, they pretty much equally target. Telecoms is as well as targeted as healthcare, and say agriculture, as well as IT. They're kind of within the same sector. Now, of course, every single sector is targeted, no matter what. Sometimes we hear and read about those stories, like, for example, another company has fallen victim to a ransomware attack. And some of those attacks will be small, some of those attacks will be very big, where the impact is actually seen throughout different government entities. Now, breaking that down into 2023, so in the first half of 2023, what we've seen is that healthcare was pretty much the vertical that is being targeted by adversaries. And the reason why that happens, most likely, is because healthcare is a very interesting mix of OT or ICS systems, as well as normal IT. So if you think about hospitals, most of the hospitals will have a life-saving devices. Those devices will be, for example, pumping air, or there will be some sort of, kind of health management systems. And really, if you look into breaking this down, you start noticing that it's actually very difficult to defend some of those devices and create some sort of detection rules and detection engineering around them. And the reason why that happens is because they're closed source, they're devices who don't have open operating systems, like, let's say, for example, Linux. There might be a specific device or specific protocol used to I don't know, get the pressure on, say, pressure pumps or anything else like that in hospital. And then when that happens, actually adversaries will look to try to exploit it. Now, of course, public health was the most targeted in Q1 2023, but we also have retail and trade, as well as real estate, food service and accommodation, and education sectors. So the way we see the attacks, sometimes we try to break them down into specific verticals, and those verticals will indicate where the adversary is focusing on. Now, interestingly, in Q2, we've seen we've seen also healthcare being targeted. So for pretty much for the first year, we've seen lots of healthcare being targeted. All kinds of different devices, all kinds of different systems. Now, we do have some reasons to speculate why healthcare might generally be targeted. Again, it will be down to staffing. There might not be enough, simply not enough money to support a large security systems or security operating environments, for example, with the number of people with the 24/7 SOC, outsource MSSPs or anything else like that to support healthcare providers. Also, of course, the mix of technologies, the IT and OT, quite often within the OT environments, you need to be a specialist within the given subject to be able to perform a sufficient emergency response or sufficient analysis to identify that there is an actual attack ongoing, while the IT environments in general are a little bit well known. And because they're well known, most IT folks will know that, for example, it's very easy to configure, let's say, antivirus to try to detect malicious files, while, for example, it might not be something that is possible within the OT environment. Now, in terms of data, of course, that holds a lot of weight. Healthcare is the kind of environment that is, if it's targeted by adversaries, it's very difficult to recover from. If you had a hospital, for example, that was ransomware, and the data was taken, and it's not something that people can change. You cannot change your DNA as much as you wish, very easily, and because that happens, then it's not like changing a password. So if the data goes missing, it's actually quite bad from the individuals who are using those services because they simply cannot go and recover that. Now, the second most targeted vertical within the Q2 of 2023 was financial services, followed very closely by utilities. Utilities for us will be typically the same kind of reasons why the OT environments might be targeted. And that is the fact that there are a mix of OT as well as IT. As well, you need to have a very specific skill set to identify and detect some sort of hacking activities within that environment. And if you don't have that skill set, then adversaries might progress and stay within the environment for years to come without anybody noticing that something is going on. Financial services, of course, financial gain, getting information and access to the data related to specific customers, especially big banks or individual, things like credit scores and things like that are prime targets for adversaries out there who are looking to understand and get exposure to individual PII data. Now, of course, in screen, you will see the link to Taos IR healthcare use case. It's one of those rare cases that we're actually allowed to publish, so I encourage everybody to visit that page, and that will give you a little bit of indication about some of the work that we did. Now let's talk a little bit about threats. So adversaries out there, what they tend to do is they tend to look for specific threats, and they tend to look for how to exploit those threats, or what kind of threats they can deploy to effectively gain access to the environment, right? The way we look at this kind of infection vectors, if you like, this is effectively the way for the adversary to get in. Now some of the organizations out there, they will deploy specific protection mechanisms to try to prevent those threats from being active or being actively exploited. Some of them will have a little bit less. And again, coming back to that staffing problem, you need to be able to monitor the environment in order to understand whether the ongoing exploitation is happening or if there is anything that is currently impacting your life environment. Now, with that in mind, in Q1, what we've seen that the biggest threats were web shells. And it's quite interesting that web shells are being seen in first quarter of 2023. Effectively, web shells are malicious scripts that enable the threat actor to compromise through a web-based service. So the threat actors might be scanning the environments, they might be scanning your internal exposed environments. They're looking for vulnerabilities. If they're finding those vulnerabilities, they might be exploiting them, and if they exploit it successfully, quite often they will deploy web shell. Now, we observed a number of threat actors using publicly available or modified web shells. They code in various languages such as PHP, ASP.NET, Perl. Sometimes they will, for example, try to trigger specific scripts using things like PowerShell. Generally, after adversaries will get their leverage access, or for example, get access to web shell, they'll try to use this to establish a foothold within the environment. They'll try to hide that web shell from the environment or from the detection, and effectively that sets them up to the persistent access that they can use to try to move around various systems and start to remotely execute scripts or commands and then move laterally within the network. Now, a lot of adversaries out there, what they do as well is they'll start bringing in additional malicious payload. So even if it's possible to say exploit a particular system, deploy the web shell, they'll use the web shell to try to download some payloads that will execute in memory. And the reason why they do this is because every time you touch the disk, so you write files to the disk and you write something specific that might, like for example, text files into the disk, then that leaves forensic artifacts that can be then reviewed by investigators such as myself to look to build for clues of how the actual exploitation happened. Now, in many cases that we've seen, the web shells, after they were deployed, pretty much they'll try to deploy additional tools. So, for example, they will try a different command and control system. They'll execute a command that will download a piece of code and run it in memory, and then this code would be connecting continuously to a specific server that was controlled by the adversary. We've seen a number of public repositories and public GitHub repositories being with web shells being used during the attacks. And that's actually very much in line with some of the trends that we observe from some of our IR engagement between July and September 2022. So Q3 2022, we've also seen a number of web shells activities happening within all kinds of different environments, also leveraging open source tools and scripts hosted on GitHub to effectively deploy and gain the initial access to the environment. Now we've seen a number of instances of pre-ransomware as well. And what is a pre-ransomware is actually quite an interesting activity. Before the adversary gains access to the environment and actually deploys a ransomware, what they'll typically try to do is that they'll try to compromise access through, for example, a web shell, or maybe brute forcing activity, maybe exploitation of the applications, or they'll try to do something else. And they'll start moving around the system to try to identify what are the interesting environments that should be exploited. So if you think about the traditional administrative management aspect, if you are finding a particular workstation that belongs to a high-level administrator, like say a Windows Active Directory administrator, then finding that workstation and then trying to backdoor it so you can see what is actually happening in that environment, it's a very, very important step for adversaries. Why? Because they like to stay in the environments for months at a time. They like to gather the data about how the organizations are operating. What are the common passwords used across the organizations? What are some of the high privilege accounts and high privilege people within the organization that might have access to additional systems? What is the data that is important to the business that if it went to go missing, might set the business years back? Like for example, a source code of a particular application that they're developing, or maybe a database of patients. And as the adversary is moving around the network, as they're effectively are looking to understand and build a kind of map of how the organization is functioning, what is the data that is important to the organization, who are the important people within the organization. Every time they move around, that also means that there is an option for us to detect them. Now, we might be doing that through, let's say, monitoring of lateral movement, or monitoring of the commands that are being executed within the different systems. That detection might happen through monitoring of, say, a particular web server, because it's very important, and suddenly start seeing new files appearing on it with no good reason. And sometimes administrators do observe that there's this activity going on. Like for example, they will see that one of their application servers suddenly starts creating strange files on the C drive, and you don't really have a good idea what happens. That's when they call emergency response to perform that forensic investigation. So other than the web shells, we also seen a lot of pre-ransomware activities. And of course, the usuals like brute forcing, port scanning, and trying to effectively gain access to administrative services is something that we've also seen in the kind of Q1 of 2023. In Q2 of 2023, what we've seen is quite interesting attacks on the data theft extortion. Now, data theft extortion is an attack that is slightly different than ransomware. The threat will simply steal the data instead of encrypting it on the disk. And what will happen is they'll then go back to the organization and say, look, we're going to disclose this, or we'll make it public unless you pay us X amount of money. It's kind of similar to ransomware, but different, because in the ransomware case, typically you have something called double extortion, which means that the adversaries out there, they will try to get into the environment, they'll try to get access to the data, encrypt it, and then also grab a copy of the data and then encrypt it. And when that happens, they might go to the organization to try to force them to pay not only for the decryption, but also to make sure that the data is not being released. And that is actually something that a lot of the governments out there, they start making very difficult to sustain. Because, for example, there are laws not being introduced, which means that if you pay for ransomware, actually that paying for ransomware become illegal. And because it become illegal now, adversaries shifted the techniques to simply stealing the data. If they can steal the data and get away with it and force an organization to pay for that data, then that means that they win in the end of the day. Now, we still see a lot of ransomware activity. Of course, we've seen activity from groups such as Ransom House or let's say Plop, and those kind of groups. What they look to do is they look to hijack all kinds of different services, like, for example, remote desktop protocols, or they look to hijack accounts or enumerate domain trusts, and effectively try to look to compromise the organization externally, either by exploiting various vulnerabilities that might be exposed to web applications or different services that organizations typically allow for remote access, as well as then once they do get in, then use some of the local trusts, or the way that the actual Active Directory, for example, are set up, or the way that the environments are set up, and then use that effectively to abuse the environment. Quite often the weapon of choice here is PowerShell, so running, for example, PowerShell scripts to recover passwords, try to modify domain policies, or simply deploy ransomware is something that we've seen out there. And of course, PowerShells are really well known as a malicious vector to a number of different threat actors. And the reason why they know is because, first of all, they execute in memory, which means that they will leave minimal footprint on the disk. And also, there's lots of tools being developed in PowerShell that effectively allows for all kinds of administrative actions to be performed across different environments. So different threat actors will come up with their own scripts, or they will try to use open source scripts from repositories such as GitHub, and they will use them to perform all kinds of interesting activities within different environments. Now, one of the interesting things that we've seen as well is the activity of the CLOP group. So CLOP is a threat actor specialized in data theft extortions. We've seen a lot of activities this quarter, so Q2 of 2023. They would get access through all kinds of interesting zero-day activities or zero-day vulnerabilities, and they'll try to get access to, for example, managed file transfer agents, looking to exploit specific CVEs that are becoming public every day. And effectively from there, they will look to exfiltrate as much data as they can from victim, grab basically anything they can grab, and then of course use that to try to extort money from the environment. So another group that also uses the extortion as a method to effectively to make money. The difference here is that the club is really looking after zero-day vulnerabilities or some of the unknown vulnerabilities, so they clearly have the skills within that environment, or within actually finding a unknown vulnerabilities, and then they use them to try to get access to different environments. Now, that's all good and well, but we actually need to talk about defense strategies as well. So, we do know that adversaries out there are looking to exploit environments. We do know that they are scanning pretty much network every day in and day out. All the time, they're looking to identify vulnerable services, unpatched services. They're looking to identify what is the so-called attack surface of the given organization. Every organization out there will expose some sort of attack surface. They might, for example, expose VPN services. There might be some sort of web server that hosts the main website. They might have interactive portals. Sometimes some organizations will have also third-party partnerships. Like, for example, they might have, let's say, a particular vendor creating website for them, or live applications that can be used by employees remotely. And then when those services get exposed and when they become part of the environment network, that is when they become part of the attack surface. So the job of the defenders is very much about reducing the attack surface, making sure that we understand what can be attacked and how to defend against those attacks from different adversaries. And the internet is being scanned all the time. Every single day, there's a scan happening across the internet. There are folks out there looking to just exploit anything they can find their hands on. Every time there is a zero-day vulnerability showing up, or for example, some unknown vulnerability or day one vulnerability, they will be trying to develop scanners that will basically go and try to exploit every single system that they can touch. Now, with that in mind, the way we kind of like to think about defending the network is a bit like a pyramid. Now, at the very bottom of this pyramid, we see the typical things that we always recommend to every single organization. Patching, right? Making sure that the patches are being deployed in the environment and actually tested. And of course, all the assets which are available externally are patched to the latest level. We do recommend, of course, asset and inventory management. So just knowing simply what is in your environment, what is being exposed, are the very much basics of cybersecurity. You cannot really defend something that you don't know, and you cannot really defend something that you have no control over. Of course, segmentation and design, quite often we like to talk about zero trust. We like to talk about zero trust related to applications. And for example, allowing certain groups of users only access to specific applications versus allowing everybody to access a particular application. Now, by reducing the number of folks who are able to access applications, you're also reducing your potential attack surface because only specific groups will be able to see the application, especially if this application is really important. Right? Like, let's think about HR systems. Any HR systems out there, if you're a management or administrator of the HR system, then that means your access should be very limited. And there should be only a few people who are able to manage and administer that given system. We like to talk about basic monitoring. So just understanding what we're actually trying to monitor, what are some of the things that are happening on the servers. Like, for example, if some of the web servers suddenly start executing PowerShell, that is a very good alert to investigate. And some of the automated systems are set up out there that would simply look for those kind of activities and tell you if something is happening. Our own Cisco Secure Endpoint, for example, does this. If it sees that there is, for example, execution of commands happening from Apache server or let's say IIS server from Microsoft, then it will alert you about that. We like to talk about backup, of course. You know, every system that is out there should be backed up, especially if those are mission critical systems. Something that, you know, some of those systems will be very important to businesses. So you know, databases, code repositories, emails. Those are some of the systems that should be regularly backed up, and they should be, of course, monitored to make sure that you can restore. So it's not just about backup, but also restoration procedure. And then finally, we like to talk about system hardening. So simply changing the defaults, making sure that there are no easy to guess passwords, you know, leaving root as a password for a router or a switch. It's not something that should be happening in the well configured environment. That is something that we should be monitoring for, changing those default credentials, for example, changing services or removing services that are unnecessary. Simply trying to reduce attack surface through system hardening is something that we always recommend for our network defenders. Now, the second level of that is a little bit more complicated. It comes with, for example, looking for information security talent, hiring the right people to do the job, hiring the people who are passionate about cybersecurity, who are looking for the ways to optimize cybersecurity, you know, accelerate the development of cybersecurity standards within the organizations is something that we always recommend for our customers to look into. Our customers should be looking out there for talents. They should be looking to use those talents to build things like security programs, which might be based on standards. You know, every organization out there who is, for example, looking to be ISO 27001 compliant, or there might be a different standard, like NIST 2, for example, that they're looking to comply, they will need to start to build their security programs around that. And they will need to start to build their understanding of how can we actually manage our technology in a secure way, and then how do we manage that technology to correspond to a certain standard that we want to be compliant with. I like to talk about things like data flow mapping as well. Quite often organizations out there don't necessarily understand where the data is within their environment, where is it flowing from and to, especially if it's like a very secure information. So looking at, for example, typical organizations, if we talk about, let's say, a source code, you know, there will be people pushing in and out code to get internal GitHub repositories quite a lot of time, but maybe only developers should be allowed to do this. If somebody's trying to download the code from, say, external resource, like say an HR system suddenly connects to a GitHub repository, try to download latest production code, that is something probably worth alerting on and talking. So if we understand that data flow mapping between different organizations, if we understand our business and how this business is functioning across our environment, and what are some of the key assets that need to be protected, then creating that data flow map really helps the defenders to try to set the plan of how the defense should be happening. I like to talk about things like GRC programs, so governance risk of compliance programs. So basically looking at the policies that the organization is to follow in order to protect the data, because those policies will also start putting certain things in motion. Like, for example, there might be a need for regular penetration testing or red teaming that happens within the organization to make sure that we understand the weaknesses and we understand some of the vulnerabilities exposed by our own organization. So governance, risk, and compliance is a very important aspect of every organization that have any data or PII elements. And there should be some sort of governance, risk, and compliance program that effectively pushes down things like risk management and how this risk management is then deployed across the organization. Now, looking very much a lot further up and to the top of our pyramid, SOC and NOC, great teams to have on board. Those are the kind of people who basically spend day in and day out monitoring the environment, making sure that if there are threats showing up on the network, then they know how to contain them and action them. And within that, what those teams typically will do, they will perform threat hunting activities to try to identify any malware or malicious activities within your environment. And quite often, those teams will rely on things like SIEM. So that would be a solution that effectively agglomerates all of the logs from within the environment and effectively make sure that if they want to perform a threat hunting, then there is a data to threat hunt on. Threat hunting is a data searching exercise. You have a lot of data, different kind of logs presented from different systems, and you need to be able to scale up your ability to search across this environment very quickly. Now, if we were to look for just top recommendations, the way we look at the threats and the way the kind of activities we've seen there from threats, we noticed that if there was a multi-factor authentication across the environment, that would effectively stop a number of those activities from happening. So if there will be simply any adversary try to gain access to say, a remote VPN, and there is a multi-factor authentication, that pretty much stops them in their tracks, right? A lot of the customers on a lot of the environments that we've seen out there are simply hacked because there's no MFA. And putting this one central protection in place that would force everybody to acknowledge their logins and make sure that we know who's trying to log into the environment that we're from, really helps to defend the environment. Now, centralizing logs is something that's very important as well. So every log that we get out there should be sent to a centralized location. That is where this threat hunting aspect will come. Limiting Windows tools, trusted accounts. So if you're an administrator, that's great. You are able to use some of those tools to perform your jobs. But if you're a normal user, there's no need for you to be able to perform administrative tasks. Segmenting the network and, of course, patching vulnerable systems. So if there's anything that you can take away from this session, those 5 vulnerabilities are the top of mind when it comes to actual cybersecurity within the organizations. All right, let's talk a little bit about Talos Incident Response Retainer, which is a flagship service from the Talos Incident Response team. So as I talked before, Talos Incident Response team is part of Talos Threat Intelligence. We are effectively the emergency incident response arm of Talos, of Cisco. And what we do 24/7, 365 days a year is we are handling customer emergencies. We are out there for our customers, no matter the day, to help them in response to cybersecurity attacks. Some of the things that we've talked about today, like the web shells or cyber breaches or anything else like that, we are there to help them to perform the forensic investigation, give them an expert remediations, and make sure that they understand what are the potential impacts to their environment and what actually transpire. That's actually a very important question that we often get during our emergency response. That, what actually happens? How did it happen? What is the timeline of the attack? Those are some of the questions that we're looking to answer. Now, the other services that we offer as well in the proactive fashion are services that effectively aim to provide our customers with much better readiness to handle incident response. So there might be, for example, incident response readiness assessments, which is an assessment aimed to understand the maturity of our customer in relation to how prepared they are for an emergency incident response. We are creating incident response plans and playbooks in order for our customers to have a solid procedure of what to do when the emergency happens. So if there is a cyber breach, they need to know basically what to do and how to do it. And that is what we're also creating for our customers. We are sometimes enhancing various team capacities in the kind of training space. So we are training our customers through cyber range or tabletop exercises on how to handle emergency response, and effectively how to perform the forensic investigation before a fully fledged incident response team arrives. Sometimes our customers just want to test themselves and identify what are the weaknesses and what are the potential areas that they need to improve. And this is what tabletop exercise provides. It's effectively a live simulation of an incident in a kind of controlled fashion. And we talk to different people about what would actually do during the emergency and how these processes will be triggered. Sometimes we hunt for adversaries as well. Some of our customers don't always have capacity to, for example, have a fully fledged SOC that is looking 24/7 into their environment and performing regular threat hunting. That's where we come into play. We actually evaluate threats and we look to identify if there is any signs of current or past compromises with the environment that would indicate malicious activity. And finally, on the occasions as well, we simulate threats. This is where our purple team exercise comes in. So we're actually looking to identify what are the weaknesses in the monitoring or detection engineering that some of our customers have in place. So that means that we'll come in, we'll actually look at what are the threats that our customer might be targeted by, what is the detection or how many detection rules they have in place that allow them to identify the malicious activity and give them recommendations of what are some of the next steps that they need to do to improve the detection. Now, I'll also leave the screen with a bit of details around some of the resources that are available. Of course, if there is an emergency incident response needed, there are 2 numbers on the top that can be called in, and I'll direct you to TAC that effectively will ask for details around what is happening, and they will let us know. And if anybody out there would like to listen or see what we do, talasintelligence.com is our main page. And with that, I'll say thank you very much.
Hello again. What a great couple of sessions. Thank you so much, Quinn and Yuri, and Matt. As always, thank you for your wonderful moderation. I am really hoping all of you found these sessions interesting and useful and are now inspired more than ever to continue leveraging our training and our certifications to grow your skills and grow your careers. Remember to take a look at our multi-cloud certifications on cloud connectivity and cloud security. And remember to stay active through our ongoing Rev Up to Research programs, our current one being CyberOps. You know, we are always developing new content to make sure that you stay up to date with the skills that are needed to build your career. So please remember, register for Cisco U. Thank you again for your time, and we look forward to seeing you in the very near future.